Hello guys, this is Mike from McProgramming.org. Today I'm going to talk about variables. I started a new Java class within my variables folder. I want to show you a little shortcut on making the main method. It may not be good. This might be for the more advanced people. As a beginner, it's probably good to get in the habit of typing it in just to really get the feel for how to make a complete program. But right here, which method stubs would you like to create? If you did this and finish, it automatically creates the main method for you, and it'll have a comment of and when it's to do in capital letters, they'll have a little checkbox right here, and that's real important when you write a huge document and you're not sure how certain things flow, so you might need to come back to a few things. And this to-do thing is great because you can see on the side there's a check mark, or even here there's a little blue mark, and you need to go back there and look at the code. For now, a way to delete a line is just click on the line and do Control D, and it'll delete the whole line for you. Another thing I like to do is go over here as close to the line as you can, right click it, and say show line numbers, and that way you can kind of keep track of what line you're on. That's kind of beneficial. But I'm going to get into integers and floating point numbers today. An integer is pretty much a number with no fractional part, and floating points have fractions. So if you are, and there are four types of integers. There are bytes, there are shorts, there are ints, which is usually the main one people use, and then there's long. A byte is 8 bits. Don't worry about all these errors because I'm not writing syntax code. I'm just trying to display what they are. So 8 bits. Short is 16 bits. An int is 32 bits. And a long is 64 bits. Let me comment this out just so I won't have all these errors. And to figure out the number that it can hold as before you have to move up to the next one. Let's say a short, or let's say a byte. I can do this one in my head. Alright, so if it holds 8 bits, what you want to do to see the maximum number is 2 raised to the 8th, which is 256. And since these are negative and positive, it's going to be, the range will be from negative 128 to positive 127, and that covers 256 available numbers. But that bytes don't do you too much good if you're trying to program with numbers. Integer is the most common one. That is 2 to the 32nd, which is 4 trillion something. So your range, I'm looking at a book right now, the range is from negative 2 million, or 2 billion and 147 million and some change, and it goes up to 2,147,000,000. So I'm going to show you how to declare an integer value. So let's just say first you need to declare the type, so int, and then you want to give it a variable name, and I'm going to give it a name, just ID. And you want to say equals, which is an assignment, and you put in a number, and it can't have fractions because that will give you an error. Let's just say my favorite number is 9, and to close this off, semicolon. So that is a very valid statement in Java, but if I ran this program, nothing would happen, so it's a pretty useless program. There's another way you can do it. You can say int ID and just declare the variable name and assign it in another place, and that's very legal too. in this situation, it would have been just best to say equals 9. And if I wanted to do a system.out.println, no quotation marks, just put in the variable name ID, and let's see what happens. Hit run, and it printed 9 down here. So that's a really cool way of not having to say print. If you said print 9, let's see what happens. Well, it'll still print 9 as an integer, or you can print it as a string. But being able to print out the variable name is very handy. Let's declare another variable. First, let's just get into the shorts. Excuse me, not the shorts, the floating points. I'm losing my mind. It's been late tonight. So what a floating point is numbers with fractional parts to it. So pi, for instance, is a huge floating point number that can't be represented completely anywhere in the world, but especially not on the computer. So there are two types: standard float, and let me comment this so I can do the same thing I just did, float. And then there is also a double. This is a 32-bit, and double is, as you can guess, a double of what a float is. This will have the float will have 7 significant digits. And a double will have 15 significant digits. If you are writing a huge program where space, the memory is a big deal, worrying about what you declare as a float and double would be important. But for writing these small programs, for me, I always just put it as a double just in case. That's a lazy programmer way of doing it, but for these tutorials, you will not have to worry about how much memory you're using up. So I'll show you how this works. Let's declare a double. Let's say I'm gonna say my grade. And a way to the customary way of naming a variable is try to name it something that when you see it, it will remind you of what it represents. So sometimes people like to say double x equals, and you'll kind of later on down the road forget maybe what that x represents. So name it something you'll remember. I'm going to say my grade, trying to give it a fractional thing. Let's say I got a 89 out of 100. Okay, so I'm not even sure what this is going to print out, if it's going to print out 0.89 or 89 over 100. It's been a while since I messed with this just simple primitive data stuff. Let's see what happens. System.out.println my grade. Close that with a semicolon. Let's see what it happens. 0.00. So let's see what happens. Maybe I have to cast this. Oh. Maybe I have to put. Well, okay. Right now I have two integers dividing each other, and it's less than 0, the amounts, because it should be 0.89. Well, it's going to just take, when you do division back in elementary school, you divide and you get how many times it divides plus the remainder. Well, right now it doesn't look at the remainder, it just looks at the division, and it doesn't even go into it, so it's going to give you a 0. So one of these at least has to be a floating point number for it to give you the correct answer. So if I just put 0.0, I shouldn't have to do it for both of them. I should just have to do it for that. That should give me 0.89. Okay, there we go. So if you're dividing two integers without any decimal points, it's going to give you a 0 for that case. So you want to put this 0.0, or you can put an F, which means float, and that will also give you, wow, that gave me a very weird digit. Well, the 0.0 was quite a bit closer, so stick with that for now. Let's say that this was over 100. Let's say it was 150. That should be 1.5, but if they're both integers, it would probably just give me a 1.0 at the bottom, and it does. So make sure you got a 0.0 somewhere, and you get 1.5. Or this is a couple tutorials ahead too. You can do a cast, and we will cast this to a double. This is perfectly legal too, and that's saying that this 150 is a double, and now it should also give me 1.5, hopefully, so I don't look dumb, and it did. So there are your two ways of your two numeric storing things: the integers, which are bytes, shorts, ints, and longs. Long would be the longer numbers, and int is pretty much your standard what you save stuff in, and short and byte are a little bit smaller memory slots, and then float and double are what you want to save your fractional numbers into. Like I said, I pretty much stick to double in it, unless memory space is a problem. Then you have to kind of, work with it a little bit, but don't worry about that right now. And the next one, I will probably get into what characters are, the next video. They're very related to, a character is just a letter, but they're very related to the int data type, so I will talk about that. Please subscribe to these videos, and I will try to keep posting them. Thank you all very much for watching, and have a good one.